Hello. So my video the first time around did not record properly, so we're going to try some different software and see if we can get this to work. I chose to use the Foursquare cipher, which is a substitution cipher. It uses pairs of letters to get our cipher text. So it breaks, as you can see in this web page, it breaks your message, your plain text, up into pairs of letters. It then uses these four separate squares, each one containing an alphabet, and uses those to get the substitution letters. So it takes the first pair, so AT, we find the A up here, we find the T down here, we take the junction of those two and we get T, and we get I down here for our first pair. And when we keep doing that for all the letters. So that was what I did. So let me show it running here. So we're going to do it with the default. So we put in the default and this is what we get. So we have all of our pseudocode here. If we scroll all the way up, our citation, etc., etc. Here we go. So let's see. So here's our plain text. I am just plain text 1, 2, 3, 4, 5 with the tilde in there. This is what we get for the cipher text after it runs through the algorithm, and then when it deciphers it, we get that back in the same format. So the way that this worked, if we walk through the pseudocode, is probably the easiest way to figure this out. Essentially, we had to have really just 3 tables. Even though there's 4, the upper left and bottom right tables are the same, and those contain one instance of each letter in the alphabet. Now in our case, normally you use a 5x5 grid that contains 25 letters, and you either ignore the Q or you use the I and the J as one letter, etc. But because we need symbols and spaces and capitals and lowercase, we went with a 10x10 grid, and we added in a few extra symbols that wouldn't normally be used just to fill that out so that we would get a usable 10x10 table. So basically what happens is we get our plain text. It's going to go in. The first thing it's going to do is actually create the tables. So it has a get tables function down here that will create those upper left and bottom right tables. And it's a very simple function. It's just an array, or a list in this case, and it just fills that in with one instance of each letter or symbol. And then we have our get key, and now we have 2 of those. We have an upper right and a lower left key, and they are different. Normally the cipher would use 2 different passwords. In our case, we only have 1 password. So what we did was actually reversed the password. So the first time around it uses it in forward, and in the second case it uses it backward, so that we get 2 different tables for our upper right and upper left. And what it will do is place each instance of the letter from the password first. So in our case, we used password, so the first letter is going to be P and then A, and so on and so forth. When we get repeats of letters, we don't repeat them. We only want one instance, so it's got to skip over any repeated letters. Once it gets to the end of the password, then it's going to fill in the rest of the table with the remaining letters in our alphabet. And by the same token, we don't want to reuse any of those letters. So we do have to make a check to verify that none of the letters already exist in our table. Once we've done that, then the rest of it is pretty easy. Then we have our algorithm here that's going to go in and find the coordinates, essentially, using our math here. And we're going to go and find the junctions. So we need to find, in our array, we need to find essentially which row and which column. And then that gives us where we want to look in our key for the first one. And then we reverse those and we do the same for the second key. And that's essentially what is happening with this cipher. So hopefully that explains it a little bit better. Maybe I can run it one more time just for the sake of demonstrating that it works with anything else. So let me run that, maybe. Okay, so let's use some random text. We'll say hello My name is John, and let's put in some symbols here, maybe a space or two, some numbers, so we have some different things there. Now we're going to put in a password, and we're going to say our password is hello world with another symbol in there. So when we run that, we should get the same thing. Puts our pseudocode in. So here's our plain text. Here's our ciphertext. Here is our deciphered text. So you can see it actually does work with something other than the default text and password. Another interesting thing that I ran into with this was because we're working with pairs of letters, we need to handle the case where we have an odd number of characters. So in order to do that, if we ended up with an odd number of characters at the very end, instead of just dropping the last one or adding some random letter to it, I added a space to the end. By doing that, it doesn't affect the appearance of the ciphertext or the deciphered text when it comes back to us, so it looks the same, even though there may be one extra space character there. So we had to modify this a little bit to work within the parameters of this software, and hopefully